All right, welcome to Bug Free Productions. This next set is going to be focused on getting our paddle set up. So, if you watched the last tutorial section on the ball, we'll be doing the paddle this time. So, paddle's right here, and we'll be focused on how to make it go left to right or right to left, based on our keyboard inputs. So the way we do that, if you followed along, there is a paddle script on paddle. And remember before you get started to go back and install this new input system. It was mentioned in the pretext video, but basically all you have to do is go package manager and install it. You search it in the Unity registry, and then if you don't have package manager open, you just go package manager right here in the window tab. So window, package manager, input system. You'll have to restart your Unity, but it's it's fine. It doesn't require any more than that. With that, we'll continue on and head into our paddle tutorial. So if we double click paddle, I'll also get restart, just all this stuff. I don't believe in it. No, start is useful for certain things, but it's not the most adaptable type of code. Um, as I mentioned before, I think, and many times in my other videos, it's just not all that adaptable because it can't run in, can't be called like inside the script. Or not inside the script. It can't be called after the scene has started. It's called when the scene starts, before updates start. So, um, it just does have its own use cases, and they aren't usually ones my style meshes with very well. So, we're gonna go and on the paddle, what's the paddle gonna need to do? Well, paddle needs to move. We need to move the paddle. And what else would we need to do? Um, we need to limit paddle velocity. So we need to limit paddle velocity. Um, so it doesn't go too fast. It doesn't start clipping through the ball. They're doing stupid stuff like that. And I'm going to switch the scene here. There we go. So our paddle class, we have this mounted behavior, we have a move paddle, and we need to limit paddle velocity. If you're watching, you're probably gonna notice a lot of misspelled words, but I think you'd rather me finish the video than go back and edit it for 2 days. So um, we're gonna go ahead and move paddle, limit paddle velocity. And we're going to, that's pretty much it for right now. So in order to do this, anytime you see an action, that's usually a pretty good sign that you're going to need to put these in the methods section of your document. We are going to need some variables in here. Accessors, I don't know if we'll need those yet, but I'm going to add them. Accessors. So to move the paddle, let's just go ahead and create a private method. Private um, void return move paddle. Move paddle. That's not what I wanted. That's, yeah, it auto completed because I accidentally void BE, no space, PADLE, no space, parameter, bracket, enter, S, save. Cool. Um, Again, this is not going to have any parameters. Why isn't it going to have any parameters? Well, because we're actually going to get a on move paddle. Yeah, because we're actually going to get a vector from somewhere else using the new input system. We're not actually going to serialize it either. We're actually just going to make it private. Um, and our new private thing has to be a vector3 because it's 3 directional. Although arguably you could make it a vector2, but there's more effort involved in that. So a movdir is usually what I put in, standing for a move direction. Equal vector3 0. We can set a default value, which is a good idea. And then, so by default, it moves 0. Move paddle, we're essentially going to, similar to what we did with the adding of the force to the ball, we're going to add force to our paddle, which is going to be, so we get a rigid body. So again, IO direction for to move. And then uh, body reference for paddle. And this will be private. And this will be rigid body. RB. Default value of null. Because it's a nullable object and creating a new rigid body would be a bad idea. Or at least in our case. In methods, we could set nope, / set up body. And where would that actually occur? That would probably occur on private void on enable. Then we're getting and setting. And then we're going to want similarly rb.freeze rotation. Set that equal to true. Then we have one more thing. We can do bracket And I'm actually going to require a component type of parameter, rigid body. Um, so you'll notice when we go back into Unity that we haven't actually added a rigid body component to this object yet, but adding this will in fact, you know, add a rigid body for us, as it requires the component or the game object that this component is added to have a rigid body. Um, do we technically need one on our uh, do we technically need one of these on our paddle? No, you could, but then you wouldn't be able to use the add force, which makes things look a little nicer. So we're gonna go ahead and move paddle, and we're going to add force when we do this. So when are we gonna do move paddle? We're gonna do it similarly to the limiter. We're gonna do move paddle actually on our cut that. We're gonna do it on our fixed update. Um, Private void. We're gonna do it on our fixed update. Now, why are we doing it on our fixed update? If you watched the last video, then you know that fixed update is our default physics frame, equally distributed, and this allows us to do all of our code that runs physics things to run on physics frames, which makes things run smoother. So we do move pad. Um, so move paddle, parameters of none because there are none. So this is all good. This is going to add force. Um, and what do we want to do? We want to add force to the rigid body. So RB dot add force. Vector 3 up, vector 3 we're going to add force in a different way than we did before. So we're going to add force of still the direction. So a move dir. And to ensure that we're using force mode dot force, which should be a smoother, more constant force, we're going to use force mode dot force. Technically this I think is the default, but if you don't put a force mode in here, but since we know what it is and what we want, we might as well define it correctly and make sure that that's true. This will also prevent if you update your Unity version and say they change what the default is assigned now, that'll help keep you from this code from changing its stuff like from force mode force to impulse, hopefully. Paddle velocity. So we do have to limit velocity. Private. Um, but what I'm actually going to do in terms of limiting velocity, and this one is a little different because we're using force mode dot force and we're not using force mode dot impulse. So we don't have to correct the amount of force that we already previously put on the ball. When we do this, so what we can actually do is, because our drag should slow us down below that 30 frames a second, we can just do if come on, if our velocity or velocity dot magnitude is greater than or actually less than the, what did I misspell velocity? Yeah, velocity magnitude less than our max. So let's go up here and define a max velocity. Or in this case, let's call it a max acceleration. Private max. Oh. Sometimes autocomplete's nice. I wish it didn't happen on spaces. I'm sure there's a setting for that too, and I'm just too lazy or out of time to do it. Max ACCELL. Hello? Axel. Um, private float Axel is equal to default float, let's say 25. Actually, I'm gonna remove max from here. Maybe? No. Max, hold on. I'm gonna go with max vel. Gonna do max vel. Yeah, I'm a little scatterbrained these days. And then we're gonna go um set accelerate set acceleration. So we're gonna go private float again. ACCELL, something like that, equal to, I think I am gonna start at 50. Um, let me see this. So why do I start at 50 here and not on the other one? I start here because this higher number is going to be applied less. So even though we had an impulse force of 10 pushing down, impulses tend to be higher at once, whereas these tend to be a little more over time um, type of concept. So your acceleration is not going to accelerate as fast as your impulse. So velocity magnitude, um, this would be max vel. So if it's less than max vel, then we in fact do the add force at force mode force. Um, and I'm actually going to multiply my move direction So first, my move direction, I'm going to make sure that it's in terms of 1. And then I'm going to also make sure that it scales with my acceleration. So this means that I can change XL to directly affect how fast move direction, how fast my paddle moves in any given direction that I'm inputting currently. So this is nice. We're still not ready though, unfortunately. So if you look at this, we now have move direction, rigid body, max velocity, and acceleration. So all of these would work normally, but because we're doing input, we still have to get our input. So what I would do here is we're not actually going to get input like we would do get access in the old system. If you've watched older videos from other people and stuff, what it actually is going to do is we're going to receive input. So um, we need a public void, and this is going to be receive mov_dir. And before we finish that, we need to use one more thing. So in order to use the input system, we need using Unity engine dot input system. So this allows us to use all the scripts in the input system. So everything in that new input system we can essentially access now, which is important because we need an input action dot callback context. I usually refer to them as ACOMs. Uh, so a context, a callback context, and we need to set our, let's do a new one. So let's do a vector 3. And let's also create a vector 2. And this is mostly just for clarity, um, which will make sense in a minute. So if we go acon dot read value, and we need a type. This is going to be vector 2. And this vector 2 is going to be, let's just call it indir. So for indirection, this is going to be called ender for new direction. So this is going to be equal to a new vector 3. And this vector 3 is going to be the x. So if we think in terms of 2D, when you move your paddle left and right, um, it's going to be on the x-axis, right? Because we're looking forward on our z. And you could change this, of course, but by default, everything's been set up for us on our z. So if we look at our z, we only want to move on our x because we don't want the paddle to move up and down, which you absolutely could, but for simplicity, we're only moving on the one rail today. So it goes x, y, z. So we need indirection dot x. So accessing the x property of the vector 2. Then we can go just zeros for the other one because we never want any input on that. So that's all good. And then once this is all good, now we have our new direction, but we didn't reassign it yet. So move, what did I do? A move direction is equal to our new direction. Um, and with our new direction, so now our new move direction should be our input that we receive. So recap quickly over this. Indirection is acon, so this is the vector to we receive as input, and then this is constructing a new direction, ECTION vector. Um, and assign su result to vector. Um, to our move direction. Limit paddle velocity. So receive, move direction, all of this should be set up. So then the last thing I'm going to do for the recording today is just to set up our movement input. So if we go to our Unity, so what do I want to do here? I saved everything up. I want my paddle to move. So now if I hit play, you'll notice both the cube and the circle fall. So both our paddle and our ball. So we could actually um, lock our X and Y position, maybe. No, not our X. Our Y and Z position. And that would work perfectly fine. Alternatively, we could put a platform under here to hold the paddle from falling. Um, so let's see if we can go to this one. And if we can, let's go on. Let's do RB dot maybe I don't remember how to do that. I don't think I've done that before. So anyway, we'll just leave it done in the inspector for now. So we'll leave those checked in the inspector. I don't have the snippet of code currently, for which to freeze that position information. But to finish this, we don't have to have it. So if we right click in our scripts folder, no, we right click in our assets folder. I'm going to create a new folder that is going to be um, input action maps. And I call it that because the only thing that's going to be in here is when I create a new input actions. So inside that folder, right click, create input actions, very bottom. Call it something that isn't generic, like PaddleCon. I put com in there, didn't I? Oh well. And if we double click, we get this window. So I want to dock this window because I don't like having undocked windows, especially during recording type things. So we're going to actually click autosave so that it saves automatically. We're not going to add any control schemes. Well, I think we're going to add a control scheme. So we add control scheme, we have new behavior scheme. Let's do keyboard. So K and okay. Yeah, this is a little broken. Okay, there we go. Yep, so you can use this and get the drop down. The UI on this isn't great, but it's okay. So I'm just going to the end and selecting. So like I did mouse, you go down keyboard, end here, click, keyboard here, click, leave it required. So now you're required to have this as a K&M scheme for keyboard mouse. So we're adding an action map, which is paddle actions. So think of this as kind of like a multiple map thing that you can switch between. So you could have certain map states of your character point to different things when you get into more complex controllers. But for right now, I'm just gonna delete this new action because I don't want the standard button action. I want something a little more descriptive. So let's add an action. Mouse. Um, you could do mouse paddle or you could do WSDA. Um, or A and D, really, which is what I would do. So I'm gonna do move, move paddle, and then no binding right now. Don't want a binding. I want to use my move paddle that I just named, change its action type to a pass through. So it's gonna pass through a value. Um, and that value is gonna be a vector 2. So we have our action type, which is pass through because we're passing through a value, and control type is vector 2. We're controlling that we send them a vector 2 of our information. So let's go ahead and create a new up, down, left, right composite. So right click your action, up, down, left, right composite. So now you'll notice to the vector, I'm going to leave that default naming. Going to look at this and we can set our paths. So we can hit this drop down over here. And we can go ahead and go, hey, I want to use my keyboard. Or what I like to do, you can't really see it because of the way they made the UI, but there's an apply button. So if you go left and you see that little dark gray become light gray behind it, you hit click and you can do listen. And this is up, so I'll hit W and then I'll click W and I'll go next. I will do listen and we'll do down. And we got S. So on, so forth. And if you have the input available, it's a really quick way to get that done. Um, if you don't have the device you're trying to use while you're setting up the input actions, you can just know the name of the different inputs. Um, but can get more difficult when you go into controllers and stuff like that, like actual game controllers, like DualShocks and 360 controllers. So I don't recommend, or it's not that I don't recommend it, but it can just be difficult. And then right here we can see use in control scheme. So we can tell all these different like inputs if they apply to the same control scheme we're using or different action maps. Cool. So with all that, that's all saved because it's auto save. And with auto save, now we can finally go back to our paddle in our inspector. So paddle, hierarchy, inspector on our right here. And we can go ahead and go mass, look at all this stuff. You notice it added a rigid body for us when it didn't have one because we used required component. And is kinematic, we don't want that. So we do need to add and input player, not input manager, we just want player input. So if we add a player input, we can choose our actions here. So what actions do we want? We want our paddle com actions. Very easy. Always click the radial. It'll show you all of the types in assets or scenes. Makes it a lot quicker than managing through this thing, this project window. Any rate, so default scheme, we can go any. There's only one in there, we don't care. Behavior, we need to make sure this goes invoke Unity events so that we can have it invoke some of our Unity events in here. And once you change that, you'll see it changes to events down here. And we can have paddle actions. So this is the ones we defined. The ones below that are device lost, regained. These are what happens when devices like Xbox controllers lose connection to the system. Not super worried about that just right now. So we'll do paddle actions. And we're actually going to have to add an action or a callback. So this is the thing that it will send a callback to, meaning every time our button's pressed, it calls this method. So we need to add our paddle. So we can drag our paddle in, or since we don't have a lot of scripts, we could have went through the scene and done that. But honestly, this is one of those times where it is easier to drag and drop. It closed. So once we drag our paddle in there, we can do our no function and change our no function from that to our paddle script. And in our paddle script, you'll notice that receive move direction is up here because all your callbacks will actually be auto sorted to the top. So we select callback, and then now that we have a callback, if we hit play, it should work if we've set everything up. So this is our test. So, I mean, it did work. Okay. Yep, that's working fine. Huh. I don't know why it slides so far off screen and then won't come back. Um, that's a separate little play area fix. We can just throw some colliders on the end and underneath it and fix that. I really think it's just like, yep, it should be fine. It's only when it goes off screen by like a lot for some reason. Okay. So anyway, it's probably because I build up the momentum and it just keeps sliding forever. Um, to change some of that, we could just go rigid body. We could up the drag and give it like a drag of 1 because it feels a little buttery, right? So you'll see there's a lot less of that. That feels a little better. Yeah, drag, you can just change how much drag is acting on the object, which will slow it down faster. I usually leave the mass at 1 and just kind of fiddle with the drag and the stuff rather than changing the mass because mass tends to affect a lot of things. Freeze position. Also, if you make the mass too light, there becomes some collision slash force issues. For new developers, it's probably not worth a whole lot of investment in using a bunch of mass calculation type things. So we have freeze position. So after all of this, we have our paddle moving left to right and not up or down. Plus we have our ball falling. So in the next one, we're probably going to look at game bricks and how to make them break and add score, create that sort of thing. And uh, that's it for today. And I'll see you then. As always, remember to drop some, feel free to drop ideas for videos in the channel or questions in the comments or ask them in the chat on Twitch. Twitch is probably not going to be all that consistent of a time schedule because of just my weird um, availability for the next while. But I'm gonna try and get the videos back up. So I hope you guys enjoy this new version of Brick Breaker, and we'll see you later.